Welcome to another episode of Programming Problems. Today we'll be performing some speedy Mirage maintenance as we work on Day 9 of Advent of Code 2023. Today's problem description boils down to something pretty short. Given a sequence of numbers, what is the next number? And then, if we are given many sequences, what is the sum of all these next numbers? Let's jump straight into the examples. As part of today's problem, we get some instructions on how the algorithm works to infer this next number. Given a list of numbers, you can construct a new list of numbers containing the signed differences between the adjacent numbers. In this example, this would be +3 at every step. Once more with the new list of threes, which gives us a difference that is always 0. At this point, the instructions tell us we can stop with checking the differences, and we should have enough information to infer the next number in the sequence at the top. In this case, this is 18. Here is a more extensive example where we already built up all the differences. According to the instructions, the final step is to add one more column to this table. In the column, we would put a 0 at the bottom, and then we go up with A, B, C, and finally D. Step by step, we can infer these numbers until we have our answer at D. So first up is A, which is 0 plus 2. Next up is B, which is 2 plus 8. Then C, which is 23 plus 10. Finally, we arrive at D, which is 68 plus 33 for a total of 101. This is the answer for this example. It is important to note that for today's problem, the direction matters, so it is not enough to just think in absolute difference. We care about the difference required when going from some number A to some other number B. This difference shall therefore always be signed, meaning that it can be positive or negative. For the solution, I want to point out that the example and the problem instructions show us a way to do it where we need information from two rows at the same time. However, this is not necessary at all. I grayed out the numbers which we incrementally inferred, but the last and most important step before the final answer was 33. If we add up all the green numbers, which are simply the last elements of the rows with differences, then you can see that they also equal 33. So for the outline of the solution of part 1, what we do is we construct the lists of differences, and we grab the last element of every list. So first we take in our lines, and per line we parse the numbers. Then for those numbers, we get the list of those last delta values per row. Then the next number is simply the sum of those deltas plus the last number in the original sequence. Here you see the algorithm with a visual example. Given the list of numbers, called nums, we first construct a list of deltas. Then while any nums, which means that we loop while any number is not 0, then we construct the next number row, which represents the differences. Then we want to loop over the numbers in pairs, so we iterate until the last index -1, and we take numbers A and B. Because we care about the signed difference to get from A to B, we append B minus A to the list. Finally, we make sure to record the last number of these differences in our deltas list, and we update nums. Eventually, we will get to the point where we return the deltas, and that's it then for part 1. Let's take a look at part 2. For part 2, we're asked to determine for any given sequence of numbers, what is the number that would come before the first number? So this is the opposite question of part 1. Given many sequences, again we're asked to give the sum of all those numbers that come before the first numbers in those sequences. Let's jump to a quick example. Here we are given 10, 13, 16, 21, 30. If we expand the rows of differences, then we should be able to infer that the number before 10 shall be 5. Do you see how you can write a simple solution for this? While you can modify your algorithm to work in reverse, a simple insight is the following. The only change that part 2 introduces is the change in direction in which we traverse the input. So the algorithm will have to change if we want to get this change of direction into our code. However, we can also change the direction of the input instead, If we reverse the input, the output shall be the same. So the outline of part 2 is only minimally changed where we reverse the parsed numbers. And that's it already. There's no more magic to show you for today's problem, and you should now be able to get both stars. Thank you once more for your interest in today's video. Please come back tomorrow for more Advent of Code solutions.